Good morning, my dear students. Welcome to the chemistry class. Today we will continue the equilibrium chapter, and today we will discuss the last part of this chemical equilibrium, that is the last Chatelier principle. There are factors influencing the chemical equilibrium. In the year 1884, a French chemist, Chatelier, studied the effect of change of concentration, temperature and pressure on large number of systems in equilibrium. And according to his principle, if a system in equilibrium is subjected to a stress, that is the change of temperature or change of pressure or change of concentration, the equilibrium shifts in such a way so as to undo the effect of the stress is imposed. Let us now discuss the effect of various factors one by one. So first we will discuss the effect of change of concentration. Effect of change of concentration. Okay. First let us consider one reaction. A plus B, reversible reaction, okay, and equilibrium, this is in equilibrium, forming C plus D. Okay. So let us consider the reaction in equilibrium. If we add A or B, or A and B both from outside, then according to Chatelier principle, the effect will be to decrease the concentration of A and B, and this is possible only if more AB will react to form the C and D. Okay, so the equilibrium shifts in forward direction. Hope you can understand. So if we add AB, equilibrium will shift to the forward direction. So more amount of C and D will be formed. Okay. Similarly, the effect of adding more of C and D, if we add this CD in this equilibrium to the reaction in equilibrium, okay, what will be the case? Okay, here equilibrium will be shift in the backward direction. Okay. In each case, the equilibrium is reestablished after some time. So it will take some time to establish the equilibrium. Now, is there any experimental evidence? Yes, laboratory experiment is there to study the effect of this concentration. The effect of change in concentration on a reaction in equilibrium can be very easily seen in the laboratory. Here we can take one example, that we can take that Fe3 plus ion. Here we can take ferric chloride solution. So it will be yellow, where will be the presence of Fe3 plus ion, or we can take ferric nitrate solution. Okay, and we can take ammonium thiocyanate solution, then you will get thiocyanate ion HCl minus in aqueous. Then when they will combine, their equilibrium will be formed, that will form FeHCl 2 plus aqueous. Okay, so in this case, this thiocyanate HCl minus, it is colorless, but it is the blood red color, okay, or reddish brown color. You can write reddish brown, or you can say blood red color. Okay, all of you have done this test in your laboratory, that ammonium thiocyanate and ferric chloride producing blood red coloration. Okay, now suppose 0.2 molar ferric chloride solution of 1 ml volume taken and 2 drops of 0.002 m, that means molar sodium thiocyanate solution is added. A red color is obtained due to the formation of ferric sulfocyanide or thiocyanate complex. Okay, whose intensity is constant after equilibrium is attained. Now if in this equilibrium more ferric salt, okay, that means ferric nitrate or ferric chloride is added to this left side, okay, or that means in the reaction mixture, then potassium sulfocyanate solution, we can all add also this cyanide also, okay, sulfocyanate solution. Then the intensity of the red color increases, showing that the formation of more FeHCl 2 plus, okay, ion. Again if to this solution a small amount of potassium ferrosulfocyanide, this one if we add, okay, then the intensity of the red color decreases, showing that the equilibrium has shifted in the backward direction. So that means when we are adding this one or this one, it is going to the forward direction, and if we are adding this APSCL, then it is going to the backward direction. Okay, and there are so many examples in our everyday day-to-day life. Okay, that clothes dry quicker when they are in a breach. Okay, or we keep on shaking it. Okay, this is because water vapor, nearby air are removed and cloth loses more water vapor to re-establish the equilibrium with the surroundings air. So we sweat, another example I am telling that we sweat more on humid day, but it evaporates when we sit under fan. So here also more sweating takes place because the surrounding air is large amount of water vapor. Okay, and our skin cannot lose more water to it, because actually in that time that air is saturated with moisture or water vapor. So air cannot take that water vapor from our body, what is coming as sweat. So when fan, if you are using fan, that wind will come, that will remove the humid air, and new fresh air will come, that will be not saturated with water vapor. So then evaporation starts, okay, and the skin will come. Hope you can understand in this way. Many examples are given in your book that you will read. Next we will discuss the effect of change of temperature. Effect of change of temperature. Okay. Now the change of temperature alters the state of equilibrium for only those reactions in which either heat is evolved, that means exothermic reaction, or heat is absorbed, that means endothermic reaction. In fact, every such reaction is made up of two opposing type of reaction. If the forward reaction is exothermic, then the backward reaction will be the endothermic reaction. Okay. Now consider a reaction, okay, which is exothermic. That is the Haber process, ammonia preparation by Boss and Haber process that we can discuss. Okay, so here nitrogen gas is reacting with hydrogen gas, forming ammonia gas. Okay, now here delta H will be minus 92 kilojoule per mole. This amount of energy will be released. Okay. So now obviously the forward reaction is exothermic, whereas the backward reaction is endothermic. Now if the temperature is increased, the heat is supplied to the system. Then according to the last Chatelier principle, the equilibrium will shift to the side that absorbs heat, and that is in the backward direction. Similarly, decreases in temperature will shift the equilibrium in the forward direction. Now you know that optimum temperature we are generally using that 450 to 500 degrees centigrade to get the maximum yield in the Haber-Bosch process. Okay. So next, is there any laboratory experiment by which you can understand, okay, that the effect of change of, yes, there is one reaction. I am writing that reaction, that twice NO2 gas, the dimerization of NO2 is forming N2O4 gas. So this NO2 gas, it is reddish brown. And N2O4 is colorless. And this is also a exothermic, this is also an exothermic reaction. Okay. And here amount of heat liberated will be around minus 57 kilojoule per mole. Okay. So NO2 gas may be prepared by adding copper turnings to concentrate nitric acid and then collected in a 220 ml test tubes. Okay. Now ensure that the intensity of the brown color, reddish brown color in the both test tube will be same. Otherwise there will be problem. Okay, if the intensity of the color is same, that means same amount of gas you have taken, and then you have to use stopper to seal this test tube. Okay, then take 3 beakers, 3 different beakers you have to take. So first beaker containing freezing mixture, okay, that means 0 degree you can use, and second containing water at room temperature, and third you have to take hot water around 90 degrees centigrade. Now place one test tube in first beaker and the second test tube in a beaker, that means third beaker. Okay, the tube in beaker 1 is almost colorless, showing that the presence of N2O4 gas. N2O4 gas is colorless. Okay, the test tube in beaker 3 has dark brown color, showing the presence of NO2. Now shift both the test tube in the beaker 2. Okay, then what you will observe? You have to wait for some time to reach the equilibrium. Both the test tube acquire the same intensity of color. So that's for the given exothermic reaction. The effect increases. Okay, the effect of increase of temperature from 273 Kelvin to 298 Kelvin is the shift the equilibrium in the backward direction. Okay, and decrease of temperature is shifted the equilibrium in the forward direction. That means whenever this is an exothermic reaction, so if we decrease the temperature, definitely it will go to the forward direction. Okay, and if we increase the temperature, then what will happen? Reaction will go to the backward direction. Hope you can understand. So this is the effect of change of temperature in equilibrium state. Next we will discuss effect of change of pressure. Effect of change of pressure. These factors play a significant role in case of gaseous reactants, okay, reactions, and those two which produced with a change in the number of moles. Okay, so consider a reaction first. Okay, suppose that reaction I am discussing, N2O4 gas. Okay, dissociating into twice NO2 gas. So here it is 1 mole and here it is 2 moles. Now here the forward reaction occurs with the increase in number of moles. Here 1 moles become forming 2 mole gas. Okay, so therefore the backward reaction must proceed with the decrease in the number of moles. If now the pressure of the system is increased at equilibrium, then according to the last Chatelier principle, the equilibrium will shift in a direction in which the pressure decreases of the number of the mole decreases, because pressure is directly proportional to the number of moles. Since the backward reaction takes place with decrease in the number of moles, so an increase in pressure will favor the combination of NO2, okay, NO2 molecule to produce N2O4. Conversely, if the pressure on the system is decreased, the equilibrium will shift the forward direction, which is accompanied by increase in the total number of moles. In other words, decrease in the pressure, okay, favors the dissociation of N2O4 into NO2. Hope you can understand. Next, another case we will discuss. Okay, this case 1. The reverse process, N2 plus thrice H2, all are gases, forming twice NH3. Okay, now in this case 1 mole nitrogen is reacting with 3 moles hydrogen, forming 2 moles ammonia. Okay, so in this equilibrium the forward reaction is accompanied by a decrease in the total number of moles. From 4 moles it is forming 2 mole product. Okay, if the pressure on the system is increased, Okay, then according to the Chatelier principle, the equilibrium will shift in that direction in which the pressure decreases. That is, the decrease in the number of moles takes place, that is in the favor of the formation of ammonia. Okay, and thus higher the pressure, the better would be the yield of ammonia. We know that the optimum pressure is 200 to 900 atmosphere to get the maximum yield of ammonia by Bosch-Haber process. In the other hand, the pressure on the system is decreased, the equilibrium will shift in that direction in which the pressure increases. An increase in the number of moles occurs, so that is in the backward direction. So in other words, a decrease in the pressure will favor the dissociation of NH3 into nitrogen and hydrogen. Okay. Next we will consider another case, that where hydrogen gas is reacting with iodine gas, forming HI gas. So here 1 mole reactant is reacting with another 1 mole, forming 2 moles of HI. Okay, 2 moles of HI. So that means here the number of moles of the reactant and the number of moles of the products. Okay, that number of moles of the reactant and the number of moles of the product is equal. So this reaction takes place in either direction. Okay, without change in the number of moles, as there is no change. Okay, so according to the Chatelier principle, pressure will have no effect on this equilibrium. So finally we will discuss these three again. That these three are very important, and the two is there I am discussing that catalyst, effect of catalyst and effect of inert gases. So in the summary we will tell that in case of concentration change, if in a reaction in equilibrium the concentration of any reactant is increased, the equilibrium shifts in the forward direction. On the other hand, if the concentration of any product is increased, the equilibrium shifts in the backward direction. And temperature change, exothermic reactions are favored by the low temperature, whereas endothermic reactions are favored by the high temperature. And pressure change, low pressure favors those reactions which are accompanied by the increase in the total number of moles, and high pressure favors the reactions which takes place with decrease in total number of moles. However, pressure has no effect on an equilibrium reaction which proceeds with no change in the total number of moles. Sorry. Next we will discuss other two factors, that is the effect of addition of inert gases. You can think about helium, neon, argon, krypton inert gas addition at the equilibrium in a reaction. At constant volume the total pressure increases. Okay. However, there will be no change in the position of equilibrium even though the pressure has changed. But when a gas is added, inert gas is added to a system at equilibrium, keeping the pressure constant, then volume of the system increases. This results the decrease in the number of moles of the gases per unit volume. Hence the equilibrium shifts in a direction which there is increase in the number of moles of gases. And finally we will discuss the effect of catalyst on equilibrium. In case of irreversible reaction, the positive catalyst will increase the rate of the reaction, forward reaction, and negative catalyst decreases the rate of the backward reaction. But in case of equilibrium, if we add a catalyst, definitely there will be no change in the state of equilibrium. There will be the rate of both forward and backward reaction will be in the same rate. Okay. So actually catalyst has no effect on this equilibrium. Hope you can understand. So in this way, today we have completed the chemical equilibrium chapter. Okay, and next day we will start a new chapter, that is the ionic equilibrium. So if you cannot understand this thing, or if you have any doubts, that you will ask in your live class. So today up to this, thank you for watching.